Agroforestry. Welcome to this lesson about innovative methods of regenerative agriculture. In the previous lesson, we covered many different techniques for forging a new large-scale agriculture. We looked at methods directly related to arable farming, and in this lesson, we will look to three very important and fortunately emerging regenerative agriculture methods or best practices, which we can see used all around the globe. These are agroforestry, key line design, two which often go hand in hand, and lastly, mob grazing, a different approach to pasture farming. As explained in Lecture 1, these three methods are just three of many best practices which fill the rich toolbox of regenerative agriculture. We have portrayed some of these already, but there are many others. Now we will zoom into the three of these, which really stand out in particular for their multiple benefits. In this lesson, we will learn the difference between agrisilvicultural, silvopastoral, and agrosilvopastoral agroforestry systems. At the end of the course, you should be able to know the different effects of agroforestry on landscapes and agricultural fields, as well as the uses and influence on yields with agroforestry. Agroforestry, which is currently receiving more and more attention, has been around for thousands of years, used by indigenous peoples throughout the world, but vanished in many areas due to the implementation of industrial agriculture. As written on the Food and Agriculture of the United Nations website, quote, agroforestry is a collective name for land use systems and technologies where woody perennials, trees, shrubs, palms, bamboos, etc. are deliberately used on the same land management units as agricultural crops and or animals, in some form of spatial arrangement or temporal sequence. In agroforestry systems, there are both ecological and economical interactions between the different components. Agroforestry can also be defined as a dynamic, ecologically based natural resource management system that, through the integration of trees on farms and in the agricultural landscape, diversifies and sustains production for increased social, economic, and environmental benefits for land users at all levels. In particular, agroforestry is crucial to smallholder farmers and other rural people because it can enhance their food supply, income, and health. Agroforestry systems are multifunctional systems that can provide a wide range of economic, sociocultural, and environmental benefits. There are three main types of agroforestry systems. Agrisilvicultural systems are a combination of crops and trees, such as alley cropping or home gardens. Silvopasture systems combine forestry and grazing of domesticated animals on pastures, rangelands, or on farm. The three elements, namely trees, animals, and crops, can be integrated in what are called agrosilvopastoral systems and are illustrated by home gardens involving animals as well as scattered trees on croplands used for grazing after harvests. End quote. This is a common picture that we see in our landscape today. Most trees, shrubs, and hedges have been removed from our landscapes. In many regions in Europe, up to 90% of the long-lasting structures provided by trees and shrubs, grown often over centuries, have vanished to make place for ever and ever larger machines and the pressure to obtain the highest possible short-term yields. Even these final reminders of at least a small touch of nature are often removed in the name of maximizing rational working. But clearly, we are losing something along with it. The last connection and space for a little bit of the natural world has disappeared, leaving few remaining spots for birds and insects, all in the name of short-term increased yields. Although we have become used to this kind of landscape, it wasn't always this way. Some 50 years ago, before the age of industrial agriculture, the sight of trees in our landscape was quite normal. This aerial photo of a region in Switzerland taken in 1946 shows the old standard. Trees are seen everywhere in the agricultural landscape. They were part of the system although already in other regions in rapid decline. They provided self-sufficiency, giving local firewood, fruits, and nuts. But within a few decades, the trees there too vanished from the landscape, making place for bigger machines and more efficient plowing and harvesters. And with it, the important functions that woody structures provide, meaning that the small islands, hedges, and strips along streams and rivers that once provided habitat no longer were existent. Now, before we delve into the additional benefits that the integration of trees and agricultural provide, let us look at some examples. As mentioned before, there are three main types of agroforestry systems. The first is the agrisilvicultural system, a combination of crops and trees, mostly in the form of alley cropping. In these systems, rows of trees are planted in specific distances from each other, taking into account multiple widths of the largest machines needed for efficient harvesting or land use. The alley width is determined by the largest machine used, so that there are a number of passes that each machine can then go through the alley. For example, 2 passes, 3, 4, 5 passes. And in between rows of trees, these alleys have been planned so that enough space is there for all of the machinery widths to pass once, twice, or 4 times the same alley up and down. Counting still to the agrisilvicultural system is the combination of trees with vegetables, which can be annual or perennial. For example, asparagus or rhubarb as a perennial example. Depending on the vegetable system used, the distance between the tree rows could depend again on multiples of the size of the tractor used, or as in the case of a tractorless bio-intensive agricultural system or vegetable system, often called market gardening, the row spacing can be determined quite flexible as no machines are used. The second system is the silvopastoral system, which combines forestry and grazing of domesticated animals on pastures, rangelands, or on farm. Some benefits are directly clear. For example, the shade of the trees for the animals on hot summer days. Or in the case with the integration of chickens, the trees serve as protection against birds of prey. As we will see in the next slides, there are even more benefits to a silvopastoral system. The 3 elements, namely trees, animals, and crops, can be integrated in what are called agrosilvopastoral systems and are illustrated by the Spanish dehesa or montado in Portugal, a system that has been known since around 2500 BC and has shaped the landscape in many Mediterranean areas. Here, the mixture of trees, mostly cork or holm oaks, give food and shade to the pigs, which graze on the meadows and which are then routinely cultivated for various arable crops. It is fascinating to take a look back in time, about 100 years ago, and to listen to what Rudolf Steiner, founder of the biodynamic movement, expressed on the subject of trees integrated in fields, or as we now call it, agroforestry. Steiner addressed yet another benefit of such integrated systems, stating, quote, "Through the correct distribution of forest, orchards, shrubbery, and meadows, harboring a natural fungal population, lies so much the essence of a favorable agriculture that the one really achieves more for agriculture thereby, even if it means reducing somewhat the usable areas of agricultural land. In any case, one does not practice a profitable economy if one uses the area of the soil to such an extent that everything I have spoken of disappears and one speculates that one can thereby cultivate more. What you can grow more of will be to a greater extent worse than what you can achieve by increasing the area at the expense of the other things." End quote. Let's take a look at some of the objectives and advantages of the integration of trees into arable farming. Before looking at the direct capital that trees provide, let's consider an important side benefit. The creation of windbreak plays in many areas around the world a crucial role in helping to mitigate erosion from vulnerable, large open and often plowed fields, while creating more favorable growing conditions for cash crops. In addition, woody windbreak structures provide habitat and food, as well as helping keep the ecosystem balanced by harboring beneficial insects and pollinators. Finally, let us imagine the contrasting picture of a rich and versatile landscape to the often monotonous agricultural fields growing a single cereal crop as far as the eye can see. These two landscapes differently influence us and our well-being as humans, let alone the environment. Let's delve a little more into the potential coming from windbreaks. In addition to the already mentioned benefits, hedges positively affect the water balance of surrounding landscapes. By reducing wind speed, unproductive evaporation from the soil and water loss from plants through transpiration decrease, and thus more moisture can be retained in the soil. As a result, crops in the area protected by hedgerows are more easily able to survive dry periods. This is of enormous importance, especially in the face of climate change. In the vicinity of the hedge, dew formation is also increased because the air humidity is higher and air movement is greatly reduced. This allows the plants to keep their stomata open longer, even in dry weather, and to photosynthesize for longer periods. The lower evaporation rate means that soil does not dry out as quickly. Soils that do not dry out as quickly or completely have a higher water storage capacity and can better absorb rainfall. The resulting reduction in surface runoff in turn reduces, for example, silting of the soil or the discharge of nutrients and pesticides into bodies of water. Numerous studies show that hedgerows increase the yield of adjacent fields when viewed on larger areas. One classical argument against the integration of trees in agricultural fields is supposed competition between trees and cash crops for water, sunlight, and nutrients. A typical farmer's reaction to the observation of an old tree standing at the side of the road or in the middle of the field are that the crops in the direct vicinity of that tree are decisively smaller in size. And yes, this observation is indeed true. In order to avoid these negative consequences on the crop, it is important to train the trees from the very beginning of the planting onwards. This requires steering the tree roots down into the soil rather than having them take the easier path of shallow rooting. This can easily be achieved by driving once or twice a year along the tree row and capping the side roots. By repeatedly capping the horizontal growing roots, the roots automatically grow vertical into the soil, enabling them to reach nutrients and water from below and thus reduce the competition for valuable resources. Trees, especially those cultivated for their use in timber, require in their early years the regular removal of lower branches or twigs as part of the so-called crown raising. Here we are striving to receive long and upright wood pieces without too large of branch holes, as well as enough space for tractors to be able to cultivate close by. The tree strip needs to be maintained properly. In the first few years, grass can be a major competition for young trees. For this reason, it is better to work with a variety of flowers or cover crops as undergrowth, and often it makes sense to hoe at the base of the tree to keep them free from grass. How can we measure the success of agroforestry in economic terms? When all production is taken into account of crops and trees, the total yield in most examples exceeds that received from a single crop on the same amount of land. Output is measured by the so-called land equivalent ratio, LER, which describes the relative area required by a single crop to produce the same biomass output as that of a multi-crop or agroforestry system. This means if the LER is less than 1, then the single crop enterprise is more productive than agroforestry. Where the LER exceeds 1, the agroforestry approach is more productive. In addition to the LER, advantages of agroforestry are, among other effects, the positive influence that woody plants have on the overall microclimates by causing a marked reduction in wind velocities and the lessening temperature extremes within the crop area. In this way, potential evapotranspiration is reduced, making more moisture available for crop uptake. LER values vary a lot depending on climate, soil, water, availability, age of the trees, management, etc. They often range around 1.2 to 1.4, but can achieve LERs of 2, indicating that agroforestry systems are more productive, can have the potential to be more productive by up to 100% compared to monocultures. The latter is especially true in tropical and subtropical climates due to increased sunlight use and the advantage of growing crops in partial or total shade. Let's now look at the objectives of integrating trees in our fields. Clearly, the production of biomass, firewood, timber, and fruits and nuts are of great interest, and from the economic perspective, enough incentive for diversifying the current farm system. Depending on the farm business plan, setting, and infrastructure, the goal can be one or many of the named products. Producing timber requires that the farmer has a long breath. Often, they are planting trees for their children or grandchildren, as most timber trees will only be ready for harvest in 70 years or more. In these agroecosystems, the goal is not to grow fast-maturing spruces, but rather to invest in really valuable high-priced species such as walnuts, chestnuts, wild cherries, and apples, maple, or oak, depending on climate, soil, and other factors. The production of biomass is another relevant product that agroforestry can provide. Here, in contrast to timber production, fast-growing trees such as poplars and willows are selected and planted in close rows, being coppiced every 5 to 8 years and subsequently made into wood chips. The wood chips can then be used for heating houses or as a valuable pre-composted mulch in vegetable production systems, and again in agroforestry systems under the younger trees. In most cases, however, we want to plant food in our agroforestry systems in order to enrich our diets and, as well, the economic base of the farm. Nut trees, such as walnuts, chestnuts, and hazelnuts, are a great symbol for permanent food production. As once planted and cared for in the first couple of years, they grow by themselves and produce large quantities of food without needing to till the soil, combat weeds, or spray pesticides. In most cases, however, we want to plant food in our agroforestry system in order to enrich our diets as well as the economic base of the farm. Nut trees such as walnuts, chestnuts, and hazelnuts are a great symbol for permanent food production. As once planted and cared for in the first few years, they grow by themselves and produce large quantities of food without needing to till the soil, combat weeds, or spray pesticides. Nuts are also a great alternative to the current status quo of grain. Other potential products are fruits and, to a lesser degree, flowers. These can be common fruits such as apples and pears, as well as fruits such as mountain ash, blackthorn, aronia, and farther. These trees, or in most cases shrubs, are plants requiring minimal care and are very resistant in respect to frosts, heat, and diseases, in addition to being rich in vitamins and minerals. Plus, one can produce high-quality products for sale from them, be it in the form of dried fruit, jam, syrup, alcoholic beverages, or other selected special recipes. A different form of agroforestry are the so-called riparian buffer zones. These zones serve to filter and take up incoming nutrient loads from the adjacent fields, preventing the leaching into the rivers and the consequent negative effects. Here, the trees and shrubs serve to absorb much of the nutrients and mitigate soil erosion. In addition to the named services, they can also be used for timber as well as creating habitat for birds and insects. A final form under the name silvopastoral systems are the forest pastures. In Europe, many forests during the medieval times here, during certain times of the year, were used to feed livestock. Here, forests were turned into multifunctional systems whereby the animals grew and fed on the forest pasture and acorns, while timber and leaf litter were collected for the use in the stable. Thank you for watching this lesson.